is about the Doppler effect. And the Doppler effect, this is a pretty interesting effect, pretty important effect. What it is a change with sound. The Doppler effect is a change in pitch that we experience from a moving sound source. So you may have noticed that if you're standing near train tracks and the train goes by, the pitch of the sound actually seems to change as the train goes past you. Now, if you're riding on the train, you don't hear any of that. Train just sounds like a train. But if it goes by you and you're standing beside it, you're not moving and the train is, you do hear a change in sound. Likewise, a police car or an ambulance or something like that, if you're standing beside the road and a police car or a fire truck or something like that goes by, you hear a change in pitch of the sounds produced by the vehicle. But of course, if you're riding on that vehicle, you wouldn't hear any change. So that's what the Doppler effect is. The Doppler effect also works with light waves. As the frequency of light waves changes, it changes our color perception. Ms. Barafato will talk more about that. But that's one of the ways. The Doppler effect is one of the key pieces of evidence that allows us to understand that the universe is expanding. Okay, now, and here's a little graph that shows kind of how it works. If you're standing and an ambulance is approaching you, the ambulance is the source of sound. As it's moving towards you, it's going to be compressing the sound waves or making the wavelengths shorter, and you're going to perceive that as a higher pitch. After the ambulance goes by you, the sound source is heading away from you and the wavelengths get stretched out, so you will perceive that as a lower pitch. So as it gets near you, it will increase, okay, the pitch, so something like this here. And then as it goes away from you, the sound pitch will decrease. Okay. Now, there's a video on this link that does a much better, given the way we're trying to do this, with this online and PowerPoints, I think this video on YouTube, if you click on this link, it will give you a much clearer explanation of the Doppler effect. So go ahead and watch that, pay careful attention to it, and then we'll answer some questions. But I think this video will explain the Doppler effect pretty well. Okay, so this next slide will give us a little chance to review. Hopefully you've watched that video on the Doppler effect. And I think that video does a pretty good job of explaining how when the moving sound source is coming toward you, the waves are compressed, the wavelengths are closer together, and we perceive it as a higher pitch. And then when the sound source is moving away from us, the wavelengths get stretched out and we perceive it as a lower pitch. Okay, so what this slide does is kind of give us a review. So let's see if we can answer each of these questions. Okay, so the first question: when does the man observe or hear? When the word observe is used here, it's we're not seeing sound waves; we're hearing them. So read it as hearing or perceiving these things. When does the man observe fewer crests? Okay, well, that would be the bottom part of the picture when the ambulance is moving away from him. The wavelengths are stretched out, there's fewer crests. When does the man observe lower energy? Remember that frequency, the higher the frequency, the higher the energy. So the lower energy would be in in the bottom picture where the frequency is lower, the wavelengths are stretched out. When does the man observe a higher pitch? Well, that would be in the top picture. The wavelengths have been made closer or squished together, so we would perceive that when the ambulance is moving towards us, we would perceive that pitch is higher. Excuse me. When does the man observe a slower speed of sound? Okay. Well, remember, wave speed, as we talked about last week, wave speed is a function of frequency times wavelength. It's not really so much important in sound, but if you multiply the frequency times the wavelength, that's where you get the greater that number, the greater the speed of sound. Okay. The next question: when does the man observe a higher frequency? Okay. Well, that's clearly in the top picture. The wavelengths are shorter. And when does the man observe a short wavelength? And that's also in the top picture. The wavelengths are shorter. Okay. So that covers the Doppler effect. The video, I think, does a good job of explaining it. And now we'll move on to light energy.